So wait another minute or so. Before we get started, who here has used Unity before? At least a little bit. You know where the buttons are and you know how to make scripts and do that kind of thing. Okay, so for this tutorial, I'm going to assume you know that. I'm going to assume you know how to add components, what most of the general components do, general scripting type things like the general setup of scripts, how to add a script, how to edit a script. It's really about it. Obviously, the more you know, the easier it'll be to follow along. So if you get lost, let me know, and I'll slow down and go back. Questions before you get started? I'm going to assume everybody knows how to code as well, so if I do an if statement, I'm just going to do it. I'm not going to explain what it does, okay? Awesome. So everyone's got the project downloaded and unzipped? Almost? That's working? Okay. So let's open that up in Unity. So start up Unity, go File, Open Project, and then, or it'll come up and it'll prompt you to open a project. Click the Open Project button.
Make sure you tell them where you launch it.
Right. Should work now since I think we've used them all, but we'll see. Right. All right. There is a bug when you open Unity, of course. Before you get to this window, sometimes it'll just say connecting, and it'll just say that forever. The first time a computer starts up with the education license. So if that happens, if it says connecting, just close it and restart it, and then you'll get to a screen that looks like this, okay? And then once you do get to a screen like this, go Open Other, and then find the project that you downloaded and unzipped. The root is GameJam tutorial. And then just select the folder, and it'll open the Unity at this project. And it should look like this. You won't see anything there yet until we open the scene, which we'll do right at the beginning. So it'll probably be blank for you. I've already opened the scene, so it's open for me. Yours won't have anything in there right now. All right, so let's open the scene now. Go to the assets on the project panel, and there's a convenient folder named Scenes. So open that. Double-click on Level, and you should look something like this now. Bunch of platforms with a knight just standing there. Okay? Raise your hand if you don't see this, because this is the beginning. About half of you. So basically what we're starting with is sort of the finished product of what we almost got to in those intermediate tutorials. So I did a little bit more work to finish them. But this is sort of the basic starting point that we did, right? And we're going to be building off that. We're going to add enemies. And basically, I'm just going to let you tell me what to do at some point. And we'll just do things and see how much of a game we can get built. Sound good? Yay. So the first thing we'll do is we'll create an enemy. Then we'll do a very, very simple enemy AI. We'll probably do we'll get the knight to attack the enemy and kill the enemy. We'll get the player to take damage, stuff like that. At the end, I'm going to show you how to make multiple levels. So maybe build a splash screen and a game over screen, and then transitioning between them. And then we'll see how much time we have, if any, at the end. And then a lot of time for questions and so on, okay? So the first thing we'll do is we'll create our enemy. And I'm going to slightly cheat doing this to save time. So select your knight and duplicate it. And if we go to the little cross arrows up here, we can move him or her all the way to the other side. And to make this the bad guy, we're going to go to the color here and just tint it darker. So this is the Dark Knight. Not Batman, the other one. And now we have our enemy. Yay. The reason I did this is then we don't have to set up all of our collision, physics detection, all that stuff. And we can reuse some of the movement too, and animations as well. There's a little property here under the sprite renderer called color. And this will, by default, it's white, so it's a normal color. And you can tint it any color you want. So make it, if you want to make a hot pink knight, that's totally fine too. I'm not prejudiced towards the color of knights. The only thing we have to change now is we have to delete the player script, because if we play this right now, they both have the same script, so they're both going to do exactly the same thing, which isn't very interesting because then they're never going to come in contact with each other. Unless you're doing a weird thing with like a mirror in between or something like that, which might be kind of cool. But yeah. So we need to get rid of the player script on this knight. So highlight the dark knight. Go down to player movement. Click on this little gear. And then remove component. And this will remove the script, which means the script will no longer be acting upon our enemy. Make sense? All right. We'll do some more setup stuff now. Just first of all, if we click play, now the enemy doesn't do the same thing as the player, so now the player can run up to the enemy. If you click, you can actually swing your sword. It doesn't do anything right now, but you can pretend to beat on the knight if you want. So on. All right. Some setup. Let's tag these knights. Who here has used a tag before in Unity? Okay, what's a tag? Somebody tell me. How do I use a tag? Or what is it used for? Yep, right. Short version, a tag can be used for anything that you can use it for, that you can think of. Usually it's used for labeling something. So putting a tag on an enemy, calling it enemy, so that then you know that this thing is an enemy if you can look at the object and get the tag. It's just a text, it's just a string, and every object can have one tag associated with it. If you have more than one, you have to be clever with how you do scripting stuff. So we're going to tag a couple things here. We're going to tag the player as player. So click on our knight here, our good knight. Click on this tag drop down here. These are all the default tags that come built in with the scene. There's already a player tag, so click on that one. And now this knight is now our player. So now we can access, whenever we look for the player, we'll look for this knight, this one here. Okay? So again, just click on the knight, drop down player. Okay. Same thing with the dark knight, only if we click on the drop down, there's no enemy or dark knight tag, surprisingly. So go down to add tag, click on that, and it'll take you to the tag manager, where this is the list of all the custom tags that you define. So if you click the plus button there, we can call this whatever we want. I'm going to call it enemy, because I'm so clever. And case does matter, so if you use a capital, make sure you use a capital at the next step later on. Okay. Once you add that, if you go back to the knight, it hasn't added this tag yet, you just created it. So now we have to actually add it. So now this enemy is tagged as enemy. The great thing about using a tag is that now if I was to create another enemy, when I write the rest of the code, no matter how many enemies I have here, as long as they're all tagged enemies, the way we write the code, they're all going to behave the exact same as this enemy when they interact with the player. So if the player hits them with the sword, if it's an enemy, it's going to die. Whether it's this one or another one that's tagged as enemy, or a rock that's tagged as enemy, it'll all die with the sword. Okay? Wonderfully morbid start to the tutorial. All right. So now if we play it, nothing changes because we didn't do anything yet. So let's add some movement for this enemy. So we're going to do some really basic AI. Basic to the sense that if the player is to the left of the enemy is going to move left. And if the player is to the right of the enemy is going to move right. So basically the enemy is just going to follow the player. Make sense? So it's really, really basic AI, but it'll actually be able to do something at the end. So let's add a new script to our knight here. Let's go down, click on the dark knight, add component, and new script. Make sure it's set to C#. If you do JavaScript, only Andrew can help you. And he doesn't want to, apparently. And we'll call this enemy AI. Spell it right. Spell it right. Create an add. Then just double click on the script here, or the one that was created here, and it'll open MonoDevelop. And then MonoDevelop is the program we use to edit the scripts. so we can sync them with the game. Okay. So raise your hand when MonoDevelop starts. Sometimes it takes a while. Although it's been faster lately, which is good. Does anybody have any errors? That's what I see. File is not a project or a solution. Okay. Does it still work? No, I got it too. I just clicked OK and it seems to work. So.
Can't get to it though.
Oh.
It's like behind the splash screen.
Try pressing the Enter key. It might be mapped to that. Yes?
Is it?
Yes.
So if there's
Victory.
like a screen behind your splash screen, hit the Enter
Just
key.
hit the Enter key and it'll magically fix it.
If it doesn't retry, no, just kidding.
Yeah.
That happening on my computer.
Just-
That's like the old Unity.
Right.
I just always have class.
Yeah. Right. Did everyone fix that issue with the pop-up? If it comes up, if there's a pop-up behind the splash screen, just hit Enter, and it should end the dialog box. Does anybody not have this right now? Okay. So just as a review from scripting, can people at the back see this, or should I make it bigger? Bigger. Is that good? Yeah? Okay. So this is the default script that Unity makes. It comes with two functions built in, start and update. All the code we write in start, this is going to be executed right at the beginning of this game. So as soon as this object, so remember this script is attached to an object, that object is our enemy. So as soon as this object is created, it runs all the start code. And then as soon as, every frame, every time the Unity redraws a screen, it's going to run update. Okay, it's going to execute that code 30 to 60-ish times a second. So we put all our initialization stuff in start. We put all of our actual game logic in update. There's also one called fixed update that uses, that's a slower frame rate, and it's about 5 times a second because it matches with the physics steps. For what we're doing, it doesn't matter if we use update or fixed update. Sometimes I split it up, sometimes I don't. That's fine. All right. So let's start with just setting up a couple class variables. It's going to be very similar to what we did in the intermediate tutorial, setting up the player, because the enemy is set up exactly the same way as a player with basically the exact same animation structure, maybe different from, I changed it from tutorial to tutorial, but it's going to be the same animation structure, so we're going to be calling the animations and movement the exact same way. Okay? We'll just write this in a separate script just as a review for what we did before. So we need a couple class variables. First of all, we need a rigid body 2D, and this is going to be a reference to this Knight's rigid body component, rigid body 2D component, which is what controls physics, like mass, gravity, that kind of thing. It also allows us to add a force for our movement. Okay, let's call it RBody. We also need a variable that's going to reference our animator component. And again, the animator is the component that handles which animation is going to be played right now. So it chooses when to transition from an idle animation to a moving animation to an attack animation, jumping animation, so on and so forth. Okay. And we're going to use this one to trigger these animation transitions by changing our animator variables that we made in the animator. I'll call this one anim. If you save it, there will be a warning here. Just click convert. I think either one works actually, but I just do that one. Let's just create a couple more variables just to save time. We'll create a public float, one called move force, another public float called max speed. So max force is every time if we're pressing down the right or left keys, that's how much force we're going to apply every time, every frame that we make a movement. And we're going to use this variable max speed, which we didn't really use in the workshops before this. And we're going to use this just to top out your speed so you don't have the exponential speed that never slows down and just keeps going if you're holding it, which a couple people brought up in the one workshop. So I fixed that for this. Yay. Let's also create a private variable, a Boolean, and we'll call this facing right. And surprise, it's true if facing right. And we're going to use this to handle flipping the sprite back and forth, moving from left to right. When you change directions, the sprite's going to flip accordingly. So this variable is going to hold which way we're currently facing. And we'll create one more right now. Oops. It'll be a public, and this is going to be a game object. So this variable type points to actually another object within the game. And this particular object is going to be the player. So every AI, or every enemy AI, is going to know where the player is right now. They're going to have a reference to that player. So they'll be able to see how far away the player is, what direction the player is from them, and all that. How much health the player has, and so on. All right. Just as a review, if we go back to the Unity editor and click on the night now and go down to the script, you'll notice all those variables that we made public are now available as part of the script. So in particular, move force and max speed were both floats. So they have little spaces there you can type in numbers. And here we can adjust how fast the player moves and how fast they accelerate to that. There's also this player. And you can't actually type anything in here. But if you click an object in the hierarchy and drag it in, you can form the connection just by dragging and clicking. So if I wanted, I could grab the knight here and just drag that. I can grab this knight and just drag that into this player slot. And now this knight has a reference to the player. So this variable is now attached to the player. You can access a player. You can change the player from the knight, from the enemy. Make sense? I'll also show you how we do that in code in 1 second for the general case. All right. So in Start, let's set up all of our initialization stuff. So we have to initialize this rigid body and animator variables. So we need to actually form the connection from this anim and rbody variable to the corresponding components that are attached to the knight. Because again, remember, this script is attached to the knight, so we can access any component that's also attached to the same object just through a line of code. So we can form this connection really easily. What else do we do? The other thing we have to initialize is we were able to drag in the player right into the game. But the problem is, in a general game, if we're spawning enemies out of nowhere, we can't stop the game and then start dragging objects in, right? So through the code, we actually need to dynamically set this variable right here in case the knight is spawning into existence and then needs to grab the player's reference on the fly. Okay? So you can drag it in if the enemy is going to be on the screen at the same time as the player, but as soon as stuff starts popping in and out, created and destroyed, you need to actually do that through code instead. Make sense? So let's do that. First of all, let's get the rbody. So this rbody variable equals get components of type rigidbody2D. If I spelled that right. And the animator is going to be the same thing, only the type will be animator. So just as a review, what this getComponent function does is it looks at the object that this script is attached to, which is the knight. It finds a component, so a thing that's also one of those things that are attached to it, that's of type or of name rigidbody2D. And the first one it finds, it grabs that and returns this, and then we set it to that variable. So it'll find the rigid body, set it, Here, same thing, it finds the animator and it sets that to the variable. So now these two things are the rigid body and the animator, essentially, right? So now we can do all kinds of stuff. Like with the rigid body, we can add a force to the enemy in any direction we want. If we wanted the enemy to move or to jump. We could also change the enemy's gravity through here or mass to make it heavier or easier to push around or harder to push around or make it fly in the air. And the animator, we can trigger the animation transitions to this variable like we did in the workshops leading up to this. All right, the third thing we have to do is we need to grab this player just in case the player can't be referenced because it's created dynamically. So we're going to use a function called find game object with ID, or find game object with tag, sorry. It's part of the game object static class. Doesn't matter. You don't have to know what that means, just that you can access it like this. Find game object with tag. And then inside the brackets here, we put a string, so something in quotes, that is actually the tag of the thing we want to find. So what is that in this case? Right, I heard player. Oopsies. Right. So it's find game object, singular. So the first object it finds as tagged as player, it grabs it. If you need more than one, you can put an S there, so find game objects, plural, and it'll give you all of the objects that have this tag in an array. Okay? Yeah.
You'd have to declare it as an array, right?
Yes, then it has to be an array type, yeah. Right now it's the game object type, so it's one game object. So if you did something like this, game object like that, then that would be an array, and then you could, types would match. Otherwise, it won't compile and it'll crash when you run it. And you'll very much know that you did something wrong because the frustration will come forth. All right, so that's all the initialization we have to do for this. So again, we just got the rigid body variable. We got the animator variable, and we made this connection between the player and the actual player. So this variable and player. Questions so far? This is mostly a review from the last workshop, if you were there, or if you've done Unity stuff before in 306 or whatever. So now let's do some actual useful stuff now. First thing we'll do is we'll create a new method down here. So void, it's going to return nothing. It's going to be called move. And all this method is going to do is add a force to the left or to the right and make the enemy move. Okay. So when we did the player, we tied this to the keyboard input, right? So when you press the left or the right arrow keys, it made the player move left or right. But now, since we're dealing with the enemy, who we can't control right now because it's an AI character, we need to have this move function, and we need to be able to call it and tell it when to move and when to not move. Make sense? So we're going to set it up very similar to the way we did the player with left and right keys, only instead of actually pressing the left and right keys, we're just going to send the exact same signal into this function so that our AI, our simple AI, can decide which way to move and when to stop and that kind of thing. Make sense? It'll make more sense when we do it as well. So this takes one argument, an integer called movement. And just so we're consistent with what we did before, right now by default, this will either be -1, 1, or 0. So it's similar to the axis. I'm not going to enforce this. You can create an enum to enforce it. I'm just going to, since it's simple enough, I'm going to do it like this, okay? So I'm only ever going to give it a number of -1, 0, and 1 for now. But you can make it an enum so that you can only have those numbers too. But I'm not going to focus on that today. So what's this function going to do? What does it have to do if this is moving the enemy? I just said it. It has to move the enemy. Not a trick question. So how do we move the enemy? Who remembers from the tutorials yesterday and the last couple weeks? We had a force. In what direction? Right. We had a force left to right. So we're going to add a force left to right. What else do we have to do? There was a second thing that we did when we added the force to make it look better. We do an animation check. We update the animation speed variable just to make sure we handle all of our transitions properly, right? So we actually move the enemy, and we also check that the animations are going to work. And the animations are going to be set up exactly like we did in the player, and we'll trigger them exactly the same way. And I'll review that in a second. All right, so add a force. How do we add a force? Yeah, force method. The rigid body has this method or function called add force. This takes a vector 2, which is just the x and y components of this force. So how much we want to go up and how much we want to go left or right, or down, I guess. So inside this add force, we create a new vector 2. Again, a vector 2 is just a special data type that has an x and a y component. It's like an array of size 2. It's got 2 elements, but they're mapped to x and y, so it's easy for coordinate systems, conceptually. All right, so this thing takes 2 things, x and y. How much do we want to move in the x? Actually, how much do we want? First of all, how much do we want to move in the y? 0, right? Because we want to move left and right, not jumping. So how much in the x? Who remembers how we did that in the player? Right. In the player, we had that horizontal axis variable, the h, and we multiplied that by the speed. Here we have our move force, and we have this movement, which is sort of replicating or pretending to be that horizontal axis, at least in value. So it'll just be this movement variable multiplied by our move force. What this will do is our move force will be a constant speed that we have set, which is constant value. But based on this movement variable, it'll determine the direction that we're adding the force. So if we multiply it by a negative number, the negative 1, minus 1, it'll move negative. Otherwise, it'll move positive. Positive, if we give it 0, it's not going to move at all. We're going to be calling this move function in here. But normally what you would do if you were making a software engineering correct game, which I totally do in my spare time when I do other stuff, you would have a move function that has this, or a move script that has this move function on it that behaves just like this. And you would put that on every object that has to move. And then you would just call that move function from wherever you're controlling that.
Can I just call the move function then?
Yes. If you make it public. Yeah. So remember how we got the rigid body component?
Yeah.
We can do the exact same thing with scripts, because they're also components. And then if you make it public, you can access it. Yeah. And yes, you could do it that way, but I'm just doing a review and so on.
I just want to know how you call functions in script.
Yeah, that's how you do it. We will maybe get to that by the end, I think. Where was I? Right. So we're going to move. So if I've played this right now, is it going to do anything? I see a couple people shaking their heads. Why isn't it going to do anything? Sorry? Because I never actually call this, right? That's one reason. The other reason is we never actually set our move force, but we'll see that in a second. So how do we call this thing? This is AI, so how do we actually call this move function? Yeah. Right? So we can check for if it's close, if it's within so many units of the player, start moving. What I'm going to do is even more simple than that. I'm literally just going to check, is the player left of me? If so, move left, or else move right. So it's basically walk towards the player, left or right. Okay. And maybe we'll add move radius after. Oh boy. Actually, first of all, let's just call this move function once just to see how it works. So if we put in -1, what's it going to do? It's going to go that way, right? It's going to move to the left. So if we click play, it's not going to do anything because we haven't set our variables yet. Right? So we click on the knight over here, this enemy knight. We have these two variables, move force and move max speed. And right now they're 0, so it's not going to move. If we change this move force variable to make it higher, then that's how fast the enemy is going to move. So let's try making it 1 and see what happens. So why isn't it moving? Any guesses? Sorry? Max speed? We're never using max speed yet, though. It's because I'm giving like 1 Newton of force, so it's not even pushing it at all. Right? Let's try 5. There. I do 5, so now he starts moving, and he stops. We'll get to that in a second. But it moved like that. So that's how the move function is going to work. If we give it a negative number, it moves that way. Positive number moves that way. If we give it 0, it doesn't move at all. Okay? So let's look at why this knight didn't, why this knight stopped. Really, it's just an issue with the physics, the way we set it up. The knight has a box collider, and so does the ground, and they're not completely necessarily even. So sometimes the corner just gets caught. So any ideas how we could fix that? Yeah. Sorry? Right, even then it's still a little bit weird sometimes. Exactly, we're going to put circle colliders around the feet so that then it's a nice round edge, so it'll just bounce off the corners and roll by. Right? Sort of like a sleigh. Let's go with that. How do I add a circle collider? Anyone remember? Right, add component. Physics 2D and circle collider. And let's add 2 of them right off the bat. They are really big circles right now. I think the radius, was it 0.75? No. 0.5? 0.3 maybe, I think. Sure, 0.3 is good. Let's make the radius 0.3 for both of them. And then use these offsets. You can use these offsets to move them around. And just place each one of them around approximately where the knight's feet are. That. Make the y the same, I guess. We also have to edit our box collider to lift that up a little bit. So the circles are below the box right there. And it's still equal with the feet. Okay, so make sure the circles, the bottom of the circles matches the knight's feet. And then click this edit collider on the box. Grab this square and lift it up a little bit. So now we have this little bit of room here where the knight doesn't get stuck. Hopefully. And why isn't it working now? Right, because we changed this value in play mode. So when we leave play mode, it resets all the values we changed. So right now it's back down to 0. Let's set that to 5 again and see if it works now. Yes, the knight didn't get stopped. But he kind of just keeps going, and you saw that it accelerated and it never actually stopped accelerating, which is also bad. So now that we've stopped play mode, let's change that to 5 again. But now we have to implement this max speed function, or this max speed variable. We have to use that. And what we're going to do with this is we're going to limit the maximum speed. So we're going to be applying the force all the time, but we're only going to apply that force if we're not already at our max speed. So if we're less than our max speed, apply the force. If we are at our max speed, which means our velocity is already at least this level, then we'll just won't add a force for a while. Make sense? You can also just clip or clamp the speed every time to the max speed. That works too. They're conceptually very similar. Let's do that up here and update. We'll put this move function in an if statement. -1, right? And what's the condition going to? What are we checking here?
If the x value of the player is greater than or less than the x value of the enemy.
Right, we'll do it in a second. Here we're just going to clip the speed first.
Oh.
Yes, we're clamping the speed, but yes, we'll be checking the x and y the x values of the enemies right away. We're just going to check if our velocity forward, whichever direction it is if it's less than our max speed, then we're going to add a force. So if we're not at our max speed yet, we'll add a force. Otherwise, we're not going to add any force. We're not going to call this move function at all. Or we can call it with 0. We can do that too. So here's how we do that. We can get our velocity with our body.velocity, and this is the current, essentially, this is the current 2D vector of our enemy's movement. So the x and y components of how fast this enemy is moving through space. So if it's moving straight that way, its velocity is x of minus whatever whatever its magnitude is, y of 0, because it's not going up or down. And then we get the x component of that. And if that's less than max speed, it means we're not at our maximum speed yet, which means we can still add another force, and we can still keep going. Make sense? Now let's see if it worked. It's always the fun part. Will it work? No, why won't it work? Because we didn't set our max speed here yet. So if I make that 2, now all of a sudden the knight will go. And he will stop at a speed of 2. Right? Make sense? And then let's make it 2 again here. Or let's make it 1 actually. See how that changes. There. Great. So now let's actually do the check for where the player is and move towards the player. I'm going to add that. Okay, let's add that here. It'll be messy, but we'll do that. So here we're going to check the position of the enemy and the position of the player, compare them, and then move in the direction that the player is relative to the enemy. All right. We'll create 2 temporary variables up here just to save some space in this condition so it's not as ugly. float player x and float my x, we'll say. And we'll set these to the x velocity, or the x positions of these two objects. Player.transform.position.x. And this is just transform.position.x. So this is just taking our player that we made, created, but that we made the connection to before, when we're getting the x position, and then we're also getting your own x position. That way we don't have to have these big long things in our condition here to stretch all the way out to there. So we just get the values ahead of time. So what's our condition check here? So we want to max the speed first. What else do we want to check? So first of all, we want to check if I am to the left of the player or if I'm to the right of the player. Which one should we do first? We'll do if my x is less than player x, which means if I am to the left of the player. So if I'm to the left of the player, what do I have to do? Which direction do I move? If I'm here and the player is here and I want to move towards the player, which way do I move? Move to the right, which means we call this move function with a +1. Okay. So here, this is my x, this is the player's x. We want to move towards the player, so it'll be move +1. We'll add an else here. We could check the same thing with the x's. We're just going to assume that we can go the other direction now. But we do have to check if the velocity's been clamped. And oh, wonderful. It's that time of the evening. Any questions so far while we wait for the computers to unfreeze? Or is it just mine? Is Merlin playing a joke on me or something? No, it does this a lot. Sorry? Yours stopped working too? We'll just wait a minute, I guess. Yeah. Any other questions so far while we wait? Oh, it's back. Yay. All right. So here, we'll check the other condition now. We know that since this wasn't true, we can know that since this wasn't true, we know that we're not to the left of the player. So we can move. Yes, that's what we'll do in a second. Exactly. So else if we will check if we're less than max speed first. So it's the exact same thing here. There is a problem with this. I'll wait for you to find it. This will be the opposite. So we'll move 0. Just to be safe, we'll check the other condition. We'll see the y in a second. Actually. Because it's easier to learn if you can see it several times. Yeah. Then I can explain it more than once, right? Then I can explain it more than once when I do it again. Yeah. Plus, I'm not a software engineer. So we're just checking the other condition now if it's greater than to the right. Oh, sorry, this should be -1. And then our final else will just be 0 for now. And eventually we'll make this, we'll try to add a buffer around the enemy so that if you're within a certain range of the enemy won't move at all. And he'll just attack or something like that. We'll set that up so you could do that for your project. We probably won't get that far. Let's see what it does. I know there's at least one bug in it, but I did that on purpose. So then he moves towards me, and I jump over him. What happens? So why does he move faster going one way and not the other way? Even when we have the same speed. Yeah.
Because you have not used absolute function.
Right. Because we're maxing out the speed going this way, but we're not checking that we're not maxing the speed going the other way. So all we're checking here is if our velocity in the x direction is less than -x. So if we're going this way, it checks it fine. But if we're going this way, it's not checking whether it's the negative velocity is greater than -x. Does that make sense? So we're only checking going one direction. If we go the other direction, it's always true because we're always negative. It's always less than our max speed. So we're just going to take this and make this absolute value of x. So it's just mathf.abs takes the absolute value. So now whether we're moving left or right, it's always going to max out the speed and clamp it. Now, down here I'll put move 0. So don't move at all. So now we got a very simple enemy AI working now, hopefully. So the enemy follows the player around. So now we have two options of what we can do next. We can either add attack, where the player can attack and kill the enemy, or we can do separate levels and like a splash screen and a game over type screen. We may have time for both, but we may not. So who wants to do attack and kill? And who wants to do the splash screen? More people voted for attack and kill, but I think more people didn't vote at all. But I guess attack and kill wins. So we'll do attack. So now the player will be able to kill the enemy. I'll get to the splash screen if I can at the end, and some UI stuff, okay? And particle, 2D particle effects. Yes. Grr. All right. I can explain what we're going to do actually first. So right now, we have our knight, right? Our enemy, or sorry, our good guy, our player is right here. And it's got the rectangle for the body. It's got the 2 circle colliders for the feet. What we're going to do is add a sword collider to this object, which is either on or off. We're going to use a trigger, which means it's not actually going to push things when it collides with it, but it's going to send a message throughout the game that says this collision has happened. And what this will be is, whenever we press the attack button and we play the attack animation, we're also going to turn this collider on so that anything that it touches, if it's an enemy, that enemy will die. Make sense? Okay. And then within about half a second, that'll just turn off again. So it's sort of simulating a sword swinging without actually having to put a collider on the entire sprite animation on the sword. Make sense? Hey, and it's working again. Oh, no, it's not. I don't think they have Visual Studio, and I don't know how to use Visual Studio at all, so I would be lost and bad things would happen. Yeah.
Can you open up like
Maybe
another text editor and just like type in it?
but it's not just that, it's the entire computer.
Oh, really? Do you want me to get Merlin?
At this point, it would take longer to fix it, I think.
Just easier.
Mm-hmm. Wonderful. If you have any bugs or errors right now is the perfect time to fix them because we can't do anything else right now. Is it a network issue, do you think? Is it a network issue or something?
Yeah, but you're connected to the like thing. I wonder if Matt's having issues. I'll go find out.
Okay.
Or I'll ask Marla if there's an issue on the network.
Okay. Any burning Unity questions you've always wanted to ask and never could have answered before? In the last hour and a half that you've been using Unity for some of you? Is it the other lab too? Yay, technology. Yeah. I've only ever used Unity. I've used Unreal for like 5 minutes. I think they're both good for different things. I feel Unity gives you more freedom. Oh no. Bad things are happening. All right, it's working again. Yay. So we added the absolute value to this value here. We'll also add it to this other velocity check. The x velocity here, same thing. So now it'll work going both ways. Right. So now you should have something like this. Where the knight follows you, the values might be a little different if you tweak them or if I tweak them. Right? But the knight follows you around and its speed gets clamped at the maximum speed. And you can change that max speed value. Right. So, first of all, in our script now, we're going to create one more variable up here, right below player. This is also going to be a public game object. Only instead of a reference to the player, this is going to be a reference to this sword collider right here. Okay? So essentially what we'll do is every time we click the mouse button, every time we click the attack button, we will turn this sword collider on to check for if we're hitting an enemy. And then about half a second later, we'll turn it off. So save that, and then if we go back to Unity, oh, actually, we have to add this to our player script, not the enemy script, right? We would need it in the enemy script eventually as well. So on our player, let's open our player script too, which is player movement, which works very similar. So now we're in our player movement script, and we'll add that variable here as well. And convert. All right. So now we have this public game object variable that we can now drag in this sword object. So for now we have to make the sword object. So back here, notice that on the script, there's now a sword little block here. And we'll drag in our sword when we create it. So how do we create a sword? Ideas? A sword collider. We'll use an empty game object. So remember how we use the empty game object to create platforms sometimes in some of the workshops? We'll do the same thing here. You can do Shift-Alt-N or right-click, create empty. And it'll create a game object. But all this game object has attached to it is its position in space, its rotation in space, and its scale in space. So it's just essentially a position, a point in world. We'll add one component to this, and that component is going to be a box collider. So down to physics 2D and box collider 2D. And then we have to look for where it is. It's over here. So let's click on this double arrow here. And just move that over on top of the knight approximately. And resize the collider to about where the sword is when he swings it. And however big this is going to be the attack radius or the attack area of your attack when you swing your sword, when you attack. You could also do this, you could do a circle as well for that. I'm going to make it a little bit taller actually. That should be good. Right? Let's also rename this object sword just so we don't get confused. So at the very top we can rename it sword. And let's create a sword tag as well so that we can handle collisions in a second. So add tag. In addition to enemy, we'll create one called sword. Like so. Right. Last step we'll do, we'll take this sword object and we'll make it a child of the player, of the knight, which means now this sword will follow the knight around when the knight moves. So if the knight moves, this sword will be relative to the knight all the time. So just click on the sword and drag it on top of this knight object. And now the sword is part of the knight's hierarchy. So now if I move the knight around, the sword follows the knight. Okay. And since we don't want the knight to automatically attack unless we press the attack button, by default, we'll have this sword collider turned off. So if you go to the sword object, you can uncheck this box collider here, and that'll turn off. And what we'll do is every time we press the attack button, we're going to turn this back on, and then turn it off half a second later. Make sense? Okay. Right. Also, we have to drag in the sword to this slot in the script. So where we created a sword variable, just drag in the sword object, and now that variable points to the sword, so we can easily turn the collider on and off. All right, back to the script. Go down. Here is where we're attacking. So here is where we're going to turn the sword on. Right after we change our animation, and right after we make our velocity 0, we're going to turn this sword collider on. We can do that through this sword dot get component. We're going to do collider 2D. We could do box collider 2D to be specific, but if we do collider 2D, it'll work if we decide to change it to a circle collider or a edge collider or another kind of collider. And then it has this property called enabled. And we want to attack, so we want to turn this collider on, so we'll make this true, which will now turn the collider on. Okay. So again, we have this reference to our sword. We have the getComponent method that gets the collider, so we get the reference to the collider. And then we just turn it on, which means now once we turn it on, any enemy that's touching it is going to register a signal from that sword that it's touching that it needs to die. Make sense? Okay. The other thing we have to do now is you have to turn this sword off because we don't want the knight to walk around with the sword always swinging if you're not actually intentionally swinging. So we're going to call a special method here called invoke. And invoke takes two things. It takes the name of the method that we want to invoke and how long we want to wait until we call that. So instead of calling it right away, we can set a method that turns the sword back off, and we can call that in half a second, for example. So we can schedule this thing to be called in the future without it being called right now. Make sense?
Unity-specific function? That sounds really interesting.
There's similar things in JavaScript. Yeah. And C#, I believe, as well. Yeah. It's really actually useful. So first of all, let's go down and create this method that we're going to do. Down below this flip function here. We'll call it just disable sword. And inside here, we just do the opposite of what we just did. So sword dot get component collider 2D. Again, collider 2D instead of box collider 2D in case we decide to switch to another kind of collider 2D in the future, which saves a little bit of code there. But enabled, and this time it's going to be false because we want to turn that off. Right? So if we go back up to where we invoke, we have this invoke set up here. First thing is the function name, which is disable sword, right? And we're going to call it in 0.5 seconds. Put an F there for float. I believe you have to. So when you press the sword button now, when you press the attack button, the sword animation plays. This sword is instantiated into the game, or the collider is turned on for half a second, and any enemy that touches it within that half a second is going to disappear and be killed from the game. Make sense? So now we actually have to set up this collision detection between the sword and the enemy. And we will do that on the enemy, I believe. No, the sword. We'll do that on a sword. It's better. First of all, let's check that this is working. Oops. All right, so I'm going to split the window here so I can see both at once. Yeah, I'll do that right after this. So I can move around, and if we look over here, every time I click, this sword is turned on, and so on. Okay, and then it turns off half a second later. And you can change those values if you need to. The only other thing we'll do right now is on sword, on the collider, we'll use this, check this is trigger. And all that does is it's not going to actually push the knight anymore. It will just register the collision, but it won't actually push the collision. Okay. So now we'll take about 5 minutes just to catch up anybody who's behind right now. The last thing we'll do is we'll wire up the collision with the sword and kill the player, okay? Or kill the knight. So if you have a few errors left, that's fine. I'm just going to finish this up. Then I'll take questions and help people fix their projects and stuff like that, okay? Okay. Awesome. We're still 7, right? Yeah. Okay. Just making sure it's almost over and I'm not making stuff up. All right, so if we click on our knight and go to the sword that we created, we're going to add a new script to the sword. We'll just call this sword controller creatively or something similar. And open that in MonoDevelop. Now we don't need the start and update, so you can get rid of those two, all this code in here. All this script is going to do is detect when it collides with an enemy. Okay. So the whole purpose of this is whenever a collision occurs with the sword with something, it checks if it's an enemy, and if so, it kills the enemy. Okay. Convert. Yeah, something like that. So we'll create this special function. So just like there's start and update that do special things, there's this onTriggerEnter function that also does special things. This is called whenever a collision happens with a trigger collider that's attached to this object. So again, this object is the sword, and we set that collider as a trigger, which means whenever anything that also has a collider comes in contact with that trigger collider, this code is executed. Make sense? It takes one argument, which is passed in by default, so you don't have to handle this, how this comes in. So type collider2D. And this we can use this collider2D variable. This is the thing that it's colliding with. Okay? So in this case, this is going to be the enemy. So we're going to use this call variable here to reference the enemy and eventually destroy the enemy through this. Make sense? All right. First thing we'll do is we'll do a check here because we want to know what this thing we're colliding with is. Because this thing could be an enemy, but if you were to make this game into a multiplayer game, this thing could be your person you're playing with. So you don't want to hit them with a sword, probably, unless it's a friendly fire game. Or it could be a wall, and you don't want to just destroy walls unless you're allowed to do that. So this could be anything that it collides with. It could even be the ground if the sword somehow touched the ground, right? So we want to make sure that this thing is an enemy first. We can do that by checking in the if statement here. Call.gameObject. So this just gets a reference to the actual object that this collider belongs to. So the thing, in this case the enemy object, and .tag, that checks the tag. So we're going to check if the tag is equal to enemy. So remember at the beginning we tagged our enemies as enemy. So this is where we're using that. We're checking if this thing is an enemy, basically. So if it's an enemy, we want it to be destroyed because we hit it with our sword. And lastly, it's just destroy, call.gameObject, and that destroys the thing. Okay. Does that make sense? So let's make sure it works before it makes sense. That's usually a good line of reasoning. And there's an error, yay, line 9. Missing a bracket. I usually do that, yes.
Oh, at the beginning, after the if.
Thank you. Play it. And we kill the enemy. Yes. So that's the basics of how you can do more of the combat side of things for your game. How would I handle that if I wanted to, instead of having one hit, if I wanted to give the enemy an actual health? How could I change it? Right. So you'd have to create a health variable somewhere on the enemy, or add another script of just variables for the enemy, and it's like state variable type thing. And then in the script here, instead of destroying it, you'd have to access that script and deplete the health. So just take away hit points from the enemy, and then also check if the hit points are at 0, and if they are, then you would do this destroy. Make sense? All right, I think we're out of time. Is that right? More or less? So I'll stick around to fix some of the projects that aren't quite working right yet, or if you have any questions, come ask me. I'll also be around most of the weekend when you're working on your games, so we'll be doing a lot more together, I guess. All right, thanks for coming out. I will see you all tomorrow sometime. Thank you.